All right, now that you've done the power rule, let's learn some simple trig derivatives. So these 6 are ones that you're going to have to memorize. The derivative of sine is cosine. The derivative of tangent is secant squared. The derivative of secant is secant tangent. Now notice as I'm writing these, when I say them, I'm not saying of x, but remember that a trig function without an argument makes no sense. So it's, make sure that you put the arguments in there. The derivative of cosine is not sine, it's negative sine of x. The derivative of cotangent is negative cosecant squared. And the derivative of cosecant is negative cosecant cotangent. So those 6, you need to make flashcards, you need to do something that you should be able to rattle those off very, very, very easily. And once you have those memorized, then the derivatives of adding them together, or I can now intersperse trig things into derivatives you already know how to do. Notice that this one, if I had a 4 in front, remember by our limit properties, if you have a constant, you can take that out. So in the same way, it's just going to be 4 f prime would be equal to 4 cosine of x. The derivative of cosine is negative sine, but there's a 2 in front, so it would be minus 2 sine of x. It's that quick. Let's look at the second one. Remember that this tangent over 5 really is just like 1/5 tangent. So having that over 5 is really the same thing as that. And again, I'm just, once you have the memorization, the derivative of tangent is secant squared. So I have 1/5, I should put f prime equals, I should label stuff, as should you. So I will go back and make sure I label. So f prime of x is 1/5 secant squared. And then the derivative of negative cosecant, if the derivative of cosecant is negative cosecant cotangent, then the derivative of negative cosecant would be positive. So this is going to be plus 3 cosecant, put it in there, cosecant cotangent. So it's just a matter of learning those derivatives. And I'm going to show you something before we go on. This is something that kind of helps some people with sine and cosine, because the positive and the negatives end up getting kind of confusing, and this just, if this helps you, then so be it. If you think about the unit circle, like over here cosine is positive, here sine would be positive 1, over here that's like negative cosine, and here would be negative sine. So remember, cosine is like x and sine is like y. And so I think you see where I get those. You're on the y-axis, so it's positive and negative, and then cosine is x, etc. If you want to take the derivative of those things, notice that the derivative goes this way. So you go in a clockwise, that would be the derivative. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. And of course, the derivative of negative cosine is sine. So that's just a little picture that some people like to draw on their paper because it just kind of keeps it straight in their head. Use it if you like. If you don't, then don't worry about it. Whoa, that's big. All right. Let's look at these two. What's the derivative of secant of x plus 2x to the fourth plus 3? Well, I can mix trig and non-trig, so I'm just going down the line. I'm just rocking down the line. The derivative of secant is secant tangent. And the derivative of 2x to the fourth by the power rule would be 8x to the third. The derivative of 3 is 0. And so, boom, shakalaka, you're done. Now, don't get confused with example 4 because the variable is theta. Notice it says f of theta. So you're taking the derivative with respect to theta. So you have to treat the theta like you would an x, which is sometimes weird, but you just have to kind of keep it straight in your head. So f prime of theta, what's the derivative of cotangent? Negative cosecant squared. So that's going to be negative 8 cosecant squared of x. Not x, theta. Now this plus theta squared, remember theta is our variable, so you have to think about how you would take the derivative of x cubed and just change the x to a theta. So it would be 3 theta squared. And then what's the derivative of negative sine? Well, we got to think, or use our little picture up there if we have to. The derivative of negative sine is negative cosine, so this would be minus cosine of theta. So, as you can see, once you have the memorization down, it's not that they're difficult, but the problem is that many times this is on multiple choice, so one little negative that you messed up is going to cause you to miss the whole thing. So you need to make sure that your memory is solid and you get these down. No trig derivatives. Let's do some equation of the tangent line. Same question, you just have trig involved. So go through your steps. Remember, if it's an equation of a tangent line, there's usually like 3 lines and then an answer. So see if you can pause the video and work this one out and see what you get. All right, I'm going to start with f of 5 pi over 6. I get my point first because I need a point and a slope. So that's really 6 sine of 5 pi over 6. If your unit circle has escaped you, you need to get him back because you have to make sure that you remember the unit circle. So 5 pi over 6 is right here. So the sine of that is going to be 1/2. So this would be 3. So my point is 5 pi over 6, comma 3. So I've gotten my y-coordinate. Now I need to find the slope at 5 pi over 6, but let me go ahead and just write the derivative down. What's the derivative of 6 sine of x? That would be 6 cosine of x. Now I have to evaluate that at 5 pi over 6. So I'm going to do 6 times the cosine of 5 pi over 6. And that would be 6 times square root 3 over 2. Negative square root 3 over 2. And therefore it is negative square root 3 over 3. If I simplify, so I have my point, again I have my slope, so it's y minus the y-coordinate is slope, negative square root 3 over 3 times square root of 3, x minus 5 pi over 6, and you know that you are going to leave it just like that. And there, my friends, is the trig. So that's what you'll be doing. Take this time, take this evening to get these guys really, really, really in your head. Okay? Let me say this as well. when it comes to the trig and pre-cal versus calculus. Let's say this question asked you for the normal line. Okay, so this was the tangent line. It didn't ask you in the question, but let's just say it did. When you did that work, you'd get y minus 3. When you take the reciprocal of this, opposite reciprocal, so it's going to be positive, but 1 over 3 square roots of 3, I know last year in pre-cal it was a big deal for you to rationalize. Like they never let you leave a cube root or a square root or whatever on the bottom. Calculus doesn't care. Okay, they don't care. So just leave it that way. Now, obviously, if the answer was multiple choice and you had to get the answer that was there, then certainly you would have to simplify it. But what I'm saying on free response, just leave it like this. I don't care if you have if you have a square root in the denominator, it doesn't matter. Just leave it. So that's probably good news for you. Okay? Alrighty. That was it. Short lesson. Do some memory work though. Make flashcards or something. Do something to memorize. All right. Peace out.